Welcome to this presentation from Scan AI. In this session, we're going to be covering the GPU accelerated reference AI architecture solutions that we offer, all powered by Run AI GPU virtualization software. The agenda is as follows, starting with a brief look at the Scan AI ecosystem and the importance of GPU acceleration in AI workflows. We'll then cover Run AI software and its use in our development and training systems, followed by our AI-optimized storage platform. Then finally, we'll introduce our Scan AI pod architectures and look at a couple of case studies to understand the pod in action. So let's begin. The Scan AI ecosystem has been developed over a number of years to cover all the related elements of the AI journey, from development through training to inferencing. As you can see, it's made up of 8 interconnecting areas that function as a whole to produce a complete AI or deep learning solution, specifically tailored to the phase of the AI journey that your organisation is currently at. So let's take a closer look. Our AI ecosystem starts at the proof of concept phase, where you're able to test and trial hardware and software solutions in a real-world context. Our range of solutions are hosted in secure data center environments, providing integrity for your data sets. Additionally, our Scan AI team are on hand to guide you through your proof of concept to ensure that you get the most from it. Next, our GPU accelerated AI hardware ranges from workstations, EGX servers and DGX servers to deliver the best performance, whether developing or training AI workflows, coupled with a range of embedded GPU edge devices for inferencing. To complement the compute, the AI ecosystem includes a variety of flash storage platforms and high-performance networking solutions to create the perfect AI infrastructure. Next, software applications aid the development and training phases, complement the hardware, and ease the data science burden. The whole solution is backed by secure data center hosting options if required, and a range of professional services, including installation, remote monitoring, and cybersecurity. Finally, our status as a certified NVIDIA Deep Learning Institute delivery partner rounds off our AI ecosystem with in-person and online courses to further increase knowledge within your organisation. So why does GPU accelerated hardware play such an important role in AI workflows? As a parallel workload, GPU architecture is ideal for producing rapid results, directly linked to core count and memory capacity. Furthermore, when these factors are combined across multiple GPUs, performance increases considerably, especially when utilising big data sets such as millions of text fields or large image files. Virtualising multiple GPUs not only retains this boost in performance, but also adds a degree of segregation and control where you can ensure every possible resource is being used. Run AI addresses this last point by pooling whatever GPU resources you have and allowing you to view it as a single entity, to be carved up and allocated as your workflows demand. Rather than a single user hogging a machine where they may only be using, say, 30% of its capability, that remaining 70% can be put to use by other projects and users. This can also be done dynamically as more or less users require resources or priority projects take precedence. What's more, the GPUs in your pool don't have to be the same type or size and can even be across multiple devices. In the development phase of AI, the Run AI build environment allows allocation of GPU resource to many users and projects so that multiple containerized workflows can exist simultaneously on a single large GPU or across many varied ones. At the development phase, dynamic control is key, as workflows will scale quickly and fail fast, so scheduling features are crucial to ensuring no GPU resource is wasted. This means that identifying the viable models to move to the training phase will happen much faster. To support this development phase, Scan AI offers a range of GPU-accelerated workstations under our 3XS brand. These are designed from the ground up and optimised for AI and deep learning workloads, featuring up to 6 NVIDIA RTX GPU cards, NVMe SSD storage and 10 gigabit Ethernet connectivity. Software pre-installed includes an AI-optimised Ubuntu OS, Run AI virtualization software and a full NVIDIA CUDA stack with NGC support. Moving on to the training phase, the Run AI train environment comes into play. This is designed to cope with the more demanding needs of AI training cycles, where using large multiple GPUs is the norm. Here, scheduling is key, so workflows can take advantage of 24/7 operation on data center hardware, and if required, all the pool resources can be allocated to a single large project. Where possible, maximising resources in this way will lead to shorter time to results from AI models. Again, for this training phase, Scan AI has designed and developed a number of 3XS EGX server architectures featuring multiple NVIDIA A30 and A40 GPU cards over which to deploy the Run AI virtualization software. As you'd expect with any high-performance server, the CPU, storage and network connectivity options are almost infinitely customizable to tailor the ultimate training platform to match any requirements. As an NVIDIA Elite partner, Scan AI offers the range of DGX solutions from NVIDIA for Run AI to be deployed on. With server architectures, often external storage plays a larger role than that within the server chassis. Therefore, we've partnered with PNY to offer its 3S range of appliances, designed from the ground up with AI in mind, delivering up to either 150 or 360 terabytes of storage. They feature NVIDIA GPU Direct throughput speeds when connected one-to-one with a server, and the option of InfiniBand and Ethernet connectivity as required. It's this combination of EGX or DGX servers and PNY storage that form the basis of the Scan AI pod architectures, complemented by NVIDIA Mellanox switches where required, and utilising Run AI GPU virtualization software. These pods produce truly groundbreaking speeds of compute and throughput, whilst costing a fraction of what other AI-optimised data centre infrastructures may do. There are several options to choose from, each designed to address a size of workload at a certain price point, yet ultimately remaining scalable by adding more compute or storage nodes at any time as required. The starting point is for a pair of EGX servers, each with 6 NVIDIA A30 GPUs, sharing a single PNY 3S 1050 storage appliance with up to 76 terabyte capacity. The next option features a single EGX server with 6 A30 GPUs combined with a DGX A100 and a PNY 3S 1050 storage appliance with up to 150 terabytes of storage. The two larger pods feature 2 or 4 DGX A100 servers with single or multiple PNY 3S 2450 storage appliances to achieve 345 terabytes of capacity. Connectivity is provided by NVIDIA Mellanox MSN 3700 switches across all pods, and all pods feature enterprise-grade 24/7 support. So now we've looked at the pods, let's understand them in action. Firstly, we'll look at a case study by the Oxford Robotics Institute. The ORI used a Scan AI pod made up of 48 GPUs installed within multiple EGX and DGX servers, all virtualized with Run AI software. This was hosted in a secure data center to see how the ORI workflows compared to its on-site unvirtualized GPU resource. They were running various workloads relating to robotic control and radar odometry. The ORI datasets range from 1 GB to over 10 GB depending on the workflow, and employed a wide range of deep learning algorithmic techniques. ORI found its workflows hugely benefited from having pooled GPU resource. As you can see, this screenshot confirms that 46 of the 48 GPUs were fully utilised. ORI saw no need to amend any of its existing practices to accommodate the Run AI software, and the off-site nature of the architecture freed up local resource for smaller immediate tasks, and due to the nature of data loading on its usual small GPU systems, the ORI saw costs reduce when loading into a much larger GPU pool. Let's take a look at a short video from ORI regarding its use of the Scan AI pod.
At the Applied AI Lab in Oxford, we've had the pleasure over the last few months to explore with our partner Scan the use of an experimental research cluster powered by NVIDIA hardware. And in the lab, we're pursuing an ambitious research agenda looking at, amongst other things, representation learning for perception, action and interaction, and access to this experimental facility and to what is, for an academic context, really unusual HPC capacity has really accelerated our research. We've used it to investigate the use of deep generative models for quadruped locomotion and for robot manipulation. And we've also used it to learn representations for and to synthesize radar data for state-of-the-art radar odometry systems. And working with Scan on this really has had an immediate impact on our workflow. Being able to swiftly deploy containerized code onto dedicated hardware, coupled with a very intuitive interface, allowed us to allocate resources efficiently across the group. And of course, using GPUs in bash mode is awesome, as you can develop and test your code without having a beefy GPU under your desk. Scan also introduced us to Run AI, which we found exceptional in every way. In particular, the ability to run jobs on fractions of a GPU has been a game changer because it allows us to use high capacity devices in a much more efficient way. Not every experiment requires a state-of-the-art large memory GPU, so why block one for everyone else? And we were really impressed with the ability to do that. Having the opportunity together with Scan to actively shape the way this cluster can be used, and having a partner who has the vision to do something unusual, the appetite to explore the art of the possible, and who's responsive to need as it arises when using this facility, really has allowed us to create a truly useful research facility for us.
Let's now focus on a second case study by the University of Liverpool, who were interested in mapping and understanding the chemical space of small molecules. Current databases run to about 11 billion samples, but its existing hardware based on NVIDIA V100 GPUs was very limited, only processing around 150,000 molecules at a time due to the memory-hungry nature of the data. The university tested a Scan AI pod comprising of a single DGX A100 coupled with a PNY3S storage appliance. As a result, the university has been able to increase the sample size to around 6 million samples at a time due to the increased GPU processing power, an increase of approximately 40-fold. This, combined with a speed up in learning of between 10 and 30-fold, means the Scan AI pod is much more time and cost effective for the university to conduct its research. The University of Liverpool has also used the Scan AI pod to train an augmented database of 21 million parameters to learn the relationship between mass spectra and molecular structure. This has permitted the first real solution of the structure identification problem for molecules not in existing databases, and represents a real breakthrough. So as you've seen, the range of 3XS GPU accelerated workstation and server solutions powered by NVIDIA and Run AI presents an ideal platform for delivering clear performance gains within many AI workflows. These solutions are delivered fully hardware and software configured, with the range starting at just £19,000 for the entry-level AI workstation and scaling up to 1.5 million for the largest AI pod architecture. All are designed by award-winning 3XS system architects and fully supported by Scan AI's in-house engineers and professional services team. Thank you for watching, and please get in touch for further Scan AI pod information or a proof of concept trial.